everyone! In this video we're talking about prime factorization, and it's essentially the same method as factor trees, which was my last video, but it's a little bit different. So maybe we'll do 64. You always want to start prime factorization by making a factor tree. If you're not sure how to make a factor tree, I do have a video on it. 64, we want to think, what two numbers do we multiply together to make 64? Well, the best way, or a way I can think of, will be 8 times 8. 8's not a prime number, so we can keep going, make another branch on our tree. 8 is 4 times 2. 2 is a prime number, so we can circle it, and that branch is done. But 4 isn't a prime number, we can split that up a little bit more. We can say that that's 2 times 2. 2 is a prime number, so you circle it. This branch we can do exactly the same way. Say it's 4 times 2, and this is 2 times 2. For prime factorization, all you need to do is look at the numbers in your factor tree that you have circled and multiply them together. So I've got 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 would be 64. So this is just another way of representing the number 64. Depending on what grade you're in, you might leave your prime factorization just like that, or you might simplify it with the use of exponents. So if you're doing exponents, our base for our exponent is going to be 2. All the numbers at the end of our branches were 2, and how many of them were there? 1, 2, 3, 4, 5, 6. So we would say, for our prime factorization of 64, that is equal to 2 to the exponent of 6. Let's do another example, and hopefully we won't get any more 2's. So we've had 6 of them, and that's probably enough. Let's do factorization for, think up a question really quick. Let's do prime factorization for 135. I'm just going to go on my calculator. 135 divided by 5. I know it's divisible by 5 because 5 is the last number. So I'll go 135 divided by 5, and I'll get that's equal to 27. So what that tells me is 135, another way of representing that will be 5 times 27. 5 is the prime number. You can't break it apart any further than just 1 times 5, so I'll circle it. 27, even though it's kind of weird looking, it's actually not a prime number. 27 is actually 9 times 3. 3 is a prime number, so we can circle it, and 9 is really 3 times 3. So our prime factorization for 135 would be 5 times 3 times 3 times 3. And to represent that with exponents, it would just be 5 to the power of 1. You don't really need to write down the little exponent of 1. It's not really necessary. Times 3 to the how many of your branches ended in 3? 1, 2, 3. So 135 will be equivalent to 5 times 3 cubed. This is the factor tree, and that is the prime factorization.